All right, I'll share my screen and we'll get started here. Okay, so this is going to be a question like number one. I'll work through it first here. So let's say it's 1 over e squared times e to the fifth. And the instructions just say to simplify. So there's a couple of ways to do this. Option one is to write this as e to the -2 times e to the 5. And then whenever you have the bases that are the same, you add the exponents. So it would be e to the -2 plus 5 or e cubed. Option two is to write it over the other, because the e to the fifth is really e to the fifth over 1. And then here you subtract the exponents because you're dividing, and you still get e to the cubed like that,
Yeah.
or e to the power of 3. So any questions on that? We don't need to do one like this, but is that okay?
Yeah, that's good.
Okay. Now, moving to a question that you might want to have one on your own here. Let's do I don't know, 36 e to the 9 over 4 e to the fifth like this. Actually, let's make it 15. Okay, so it's really two separate problems. It's the 36 over the 4, and that's the e to the 9th over e to the 15th like that. And so
Yeah.
36 over 4 is 9. And then because you're dividing, you subtract the exponents. So it's 9e to the -6. And when you have a negative exponent, you can move it to the bottom like this.
Yeah.
Now it's implied in the instructions. So yours doesn't say it, but like if you were taking a college math class and you had like an online homework, it would say only use positive exponents. So I think there is the expectation that you write it in this form here when you're all done with that.
Yeah.
Okay, so you ready to try one on your own here for like number 2?
Yes.
Okay, so let's say it's 90 e to the 8th over 15 e to the 12th. Go ahead and simplify that for us, please.
So I got 65 over e to the fourth.
6e over e to the 4th like this.
65 over e to the fourth.
Okay, so 90 over 15 though is 6. And then the e to the 8th over e to the 12th is e to the -4. You said 65. Not sure where that came from.
I think I subtracted.
Oh,
That's what I
yes,
did.
yes.
Yeah.
Yeah, I can see that. Yeah. So the numbers divide, but the exponents do not. That's interesting. I'll remember that for a SAT prep type question I come up with, because I can see why that would happen.
Yeah.
There is something in our brains where if you do one operation two times, you always try to do it the third time if you don't reset. And so we did that in the previous problem. We subtracted 2 times. So anyway, good. So let's look at we'll look at number 4 before we come back to 3. So let's say it's e to the 8th times e to the -2 times e to the x times e to the 4x plus 5 like this. Whenever the bases are the same, you add the exponents. Now, the only thing that I don't like, or I feel like is missing from your work in number 4, is I don't see you actually like writing out the addition of these.
Mm-hmm.
And the only thing that could happen there is either missing one or just not combining things correctly. So you combine the numbers, you got 8, you got -2 and 5. So that ends up being a 1. Sorry, that means 11, not 1. And then 1x and 4x is 5x. So even though like the exponent is negative, you still add it. Even though it's
Yeah.
got an x in it, you still add it. All right, so let me give you one to try here. Do you need to get any of these notes down, or can I give you a problem?
Yeah, hold on.
Okay.
So okay.
All right, so let me just give you a small variation on this. But let's just say it's like 1 over e cubed times e to the x times e to the 5th times e to the 2x. So this is your problem here, but as a reminder, 1 over e cubed can be written as e to the -3 power. Like
Yeah. Is the last one e to the 2x or
yes,
7x?
yes.
Okay.
Sorry, bad writing as 2x.
No, it's okay.
Yeah, no bueno for me.
So it'd be e to the 2 plus e to the 3x.
Like this.
Yeah.
Yes, perfect. Okay, let's look at number 3. So number 3 is the property of exponents here. So let's go 3e to the minus 5x to the power of 2. All right, so what this really is it's really, there's a 3 and there's an e to the minus 5x, and there, I know I'm switching to brackets. If you prefer, you can visualize parentheses, or I can write them for you, but it's really two separate things inside the initial parentheses. And the three really has an exponent of 1. The e has an exponent of minus 5x. So the rule is, if you have an exponent to an exponent, you multiply the exponents. Okay, so now if you have x to the n and y to the n to the power of m, meaning two different things, you still multiply the exponents. So it's 3 to the 1 times 2, e to the minus 5x times 2, like that. You're multiplying the exponents. Somehow you have to convey this to yourself, that you're multiplying the exponents.
Yeah.
So for the first one, it's 3 squared. And for the second one, it's minus 10x. Maybe we can do a little better job of showing that like this. So the answer is 9e to the minus 10x, like that.
Yeah.
And your explanation for number 5 is perfect. It's very similar to what we're doing here. So let me give you a problem to try on your own. Do you have the notes down for this one, or?
Yes.
Great. All right, so here's one for you to try. I should say try. No, you try. Okay. Okay, so 4e to the minus 3x to the power of 3.
I got 64 over e to the 9x.
Yes. Oh, and so I didn't do that in the last problem. Like I actually think it's okay to write this as 64e to the minus 9x, but your instructor is saying, hey, I only want positive exponents, which is why you move it to the bottom, which is good. I mean, it's good that you did that. Okay, one thing we didn't do is an example like this. Let's go minus 2e to the 5x to the power of 3. So this will do it together here, because I didn't see anything like this on your practice sheet. But it's the -2 in parentheses to the power of 3, e to the 5x in parentheses to the power of 3. So the reason is that it's the whole thing, the whole number -2 is to the power of 3. not just the 2. And in this example, it doesn't actually change anything because it's still negative, but there are examples where that does matter. So let's say it's like negative 2e to the minus 6x to the power of 4. This becomes parentheses minus 2 to the power of 4, e to the minus 6x to the power of 4. So it's negative 2 to the power of 4, which is 4 negative 2's, which becomes positive 16. E to the minus 24x. So you just be very careful with that, because it's potentially something that'll give you the wrong answer if you're not careful there. If that's not clear, I can work another example, but we should move on if it is clear.
Yeah, I got that. Thank you.
Okay, fantastic. Okay, so 6 through 9 are questions about whether something is growth or decay. And you need to have a general idea of how to decide whether something is growth or decay. All right, so
Yeah.
it depends on the exponent. That's really all it depends on. So like, for example, I'll give you some examples here. E to the 3x is growth, but e to the minus 2x is decay. And e to the minus x is decay, but e to the 2x is growth. So could you verbalize here a rule for like why the ones on the left are growth and the ones on the right are decay?
The number should be bigger than or greater than 1
For growth.
for growth. Yeah.
Yeah, that's actually the correct rule, because if I give you e to the 1/2 x, do you have any idea what this looks like? Or maybe this isn't covered in your class. That's what I'm not sure about. Like it's sort of being hidden from you in this assignment.
Yeah, I don't think we've really focused on that.
Okay, because the other rule, which is not correct every time, but it's like if it's negative, it's decay, and if it's positive, it's growth.
Yeah.
And I guess that's why I'm asking, because it's like, well,
Yeah, for our class, I think he kind of just said like if it's greater than 1, it's gonna be growth, and then if it's less than 1, it's gonna be decay. So like negatives and then fractions too.
yes, and that's where I was going with this, but it doesn't sound like you've got to distinguish it that much, but that's perfect. The other thing is the domain and range we can talk about here, and then the horizontal asymptote. So it's like you're not getting the full information here. That's why I'm trying to be careful here with what I give you, because I don't want to make it more complicated than it needs to be.
Yeah.
So all of these have a +0 that's not written, and the horizontal asymptote is y equals the number after or before the e.
Mm-hmm.
So in all of these, it's y equals 0. But if you just made one of them like a +1, that would change the horizontal asymptote to +1. Yeah. And if it was, -3 over here, that would be -3. So the connection you have to make is it's really this number, which is not added to it. Now, just keeping that in mind here, there's a couple of other ways though that I could give you something like this, like 2 minus 3 e to the x, and the horizontal asymptote is y equals 2. Because the other way to write this is minus 3 e to the x plus 2. And then you can see it's that number over here to the right. But you're not getting that. So I don't want to like push that any further than this, because I don't know that you will see any more questions like that. Okay, so the domain for all of these, every single problem without exception, is all real numbers.
Okay.
The range There are actually two possibilities, but your problem, your assignment here doesn't have all of them. It's always from the horizontal asymptote to infinity. So if you look at every single problem you sent, it's 0 to infinity, 0 to infinity, because that's the horizontal asymptote. But more generally, it's whatever that horizontal asymptote is. But it also depends on whether it's whether it's got a negative in front. So see how this negative is in front here, minus 3e to the x? That changes the range. So I'll just briefly mention that here, that this is the other possibility.
Yeah.
And it's like one of those things where maybe you'll see it like tomorrow in class, or you've got something upcoming, but you're not given all the cases here.
Yeah.
So for right now, this is it. And more specifically, your horizontal asymptote has been 0 in almost every problem. So it's 0 to infinity.
Yeah.
Like that. Okay, so just to kind of get to see if, because everything you wrote is correct on your paper here, let me just give you one try problem here. Let's say it's y equals 5e to the 4x. Can you give me the horizontal asymptote, domain, and range for this, please? And tell me whether it's growth or decay.
So it's growth.
Okay, good.
And then the asymptote is y equals 0.
Correct.
And then I always get confused on domain and range, but I'm pretty sure, shouldn't it? Oh, really? Yeah.
Always, 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 always. So if you look at your graphs are smooth and continuous. That's why it's continuous, because there's no interruptions. If you think about, when you play, you're a volleyball player, right? Remember, I'm trying to remember. Like you have interruptions during your game, and that's not continuous. But when you just have a nice continuous flow, like maybe you have a scrimmage where, it's just back and forth, that's continuous. But anytime you have an interruption, that's discontinuous. And it's the same idea when you're looking at the graph of something. So if the graph goes up like this, is there any interruptions to it? Maybe you're not sure what to look for, but yeah, but there's no interruptions to this. It's just smooth. You can draw it forever.
Yeah.
So that's why it's all real numbers, or from minus infinity to infinity.
And then it would just be 0 to infinity.
Yes.
Okay.
All right, so I see us moving to 10 now, unless you have, oh, we did not do the y-intercept for any of these. I apologize. The way they write these problems, they don't, and you did a good job here of underlining it, exponential growth, decay, but it's like, oh yeah, there's the y-intercept too. So the y-intercept in all of these problems is when x equals 0. And that doesn't matter whether you're doing a line, a quadratic, an exponential, a logarithm. Like, it's always the same. You just put 0 in for x.
Yeah.
So as a reminder, do you remember what e to the power of 0 is from class?
It's gonna, I think is it just e?
It's not e. E to the power of 1 is e.
Oh, it's 1.
It's 1. Yeah, this is critical. So if I give you something like this, if I say it's 2e to the 4x, and I ask you for the y-intercept, what you're doing is you're putting 0 in for x. 4 times 0. 4 times 0 is 0. And that's where you have to remember that e to the 0 is not 0, it is 1. So this is 2 times 1, which is 2.
Yeah.
So the only problem that could be more challenging here is, let's give you another one. Let's say it's 3e to the minus 2x. Could you find the y-intercept for this one, please?
It's 3, right?
Yes. Okay. Any questions on that?
No.
All right. Okay, so we're going to move to the other side of the paper and talk about money problems. Or I'm sorry, not money. That sounded bad. Problems involving money. The English language, boy, it's so confusing to explain to other people. You know, why is it a walk side and not a sidewalk? That's another one.
That's true. I never thought of
I
that.
don't, and don't think too hard about this stuff because you'll what these aren't relevant to real life, but these are things that just anyway. So there are 2 types of problems involving money that you'll see in this class, and the first one is non-continuous. And these are the ones that you actually have in real life, non-continuous. Money is never compounded continuously in any scenario in real life. If you talk to your parents, you can ask them, and there's 2 types of money problems. There's the positive ones, which are things like savings accounts. They call money market accounts, mutual funds. Stocks are part of mutual funds. And these are when you're gaining because of the compounding, when you're doing better. And then there's the negative ones get a lot more of the they're spoken about a lot more, and you probably have heard about some of these, like a mortgage on a house, a car loan, a credit card. And the reason I say that these are negative is they're working against you. You're paying interest instead of receiving interest. And if your parents, you might consider asking them about these things, because they're much more useful in real life than any of the math that you've learned thus far. But the reason I separate them is because there's 2 different formulas here that you need to know. And so when you're looking at a problem and deciding, well, is it non-continuous or continuous? What you're looking for in the non-continuous is it'll say that the interest is computed in a bunch of different ways. It might say annually, monthly, quarterly, weekly, daily. There's a few others that it could say. With continuous, it actually generally says the word continuous in the problem. So this is a long way of me saying, like you as a student have to know it's either a non-continuous problem or it's a continuous problem, and you have to be able to differentiate between the 2. So there are 2 different formulas you need for the non-continuous, and this is the kind of thing you would need in your notes. The future value of the investment, which we'll call A, is the starting amount, P, 1 plus the interest rate divided by the number of compounding periods, to the power of n times t. So n is the number of compounding periods times t, which is the number of years. Have you seen this in class?
Yes.
Okay. They give you all but one of the variables most of the time when you're doing these problems. Now, the other one here, the continuous one, is PERT, PE to the RT. It's more straightforward. You have an interest rate and you have a principal, or you have a future amount that you want to receive. You have to know the difference between them to be able to work some problems here.
Yeah.
Okay, so let's look at a more realistic situation. You are 18, roughly 17, 18, somewhere in there.
I'm 16.
16. Okay.
Yeah.
So let's think of a reasonable scenario here. that might happen. Okay, so you have a great aunt who leaves you $10,000 because she loves you, and she says, I'm going to give you $10,000. Sound, you're like, okay, $10,000. So what are some things you could do with that money today? Like, what would be what would you do if you were allowed to spend, and let's talk about things that are positive, hopefully. You could go shopping.
Yeah,
You could maybe buy a car if you don't already have a vehicle. Maybe take a trip. I don't know. What does anything else come to mind that you might use with the money?
maybe like put in an account or something like
Well,
that.
that's the wise student inside of you trying to, and that's what I want to show you here. But it's the tendency is to want to spend it, right? Because it's a large sum of money. There's always something on your wish list, right?
Yeah.
So let's talk about why you might want to invest the money. Okay, and this is a reasonable scenario. Although I hope you don't have a great aunt that dies, because that's not very nice. Now, most investments range in their return, and this is where it gets very debatable. But a very conservative type of investment might only yield about 3%, and a much more aggressive investment could yield anything higher than this. And you'll see a lot of debate if you ever read into this. If you talk to your parents, they'll have a different opinion. Anything but 3% is essentially inflation, which means that your money is only growing at inflation, which is terrible because your money is then worth the same in the future as it is now, and you'd like it to grow. But if you look at the long-term track record of the stock market, and you pick some sort of index fund, we're just going to pick 10% just because it sounds reasonable. But you try to predict the future, but sometimes it goes up, sometimes it goes down. So this is just a like, well, let's just pick a number and see how it goes. All right.
Yeah.
So most things in real life are compounded monthly. All right. So monthly means that n is 12. Is that okay?
Mm-hmm.
All right. And now this is the hardest. This is probably the hardest part. Is like, well, how long are you going to leave this money invested? So the best thing is as long as possible. And it's hard to imagine, but someday you will be 26, 36, 46, and 56. So what's a kind of an interesting exercise is to look at the growth over these years. Okay.
Yeah.
So let's do that. So the future value is the initial amount that you have, $10,000, 1 plus. Now there's a small error in what you sent me, but you take your interest rate, which is 10%, and you divide it by the number of compounding periods, not the whole 1 plus 0.1. It's just the interest rate R.
Yeah.
And then you take that to the power of 12 times however many years. So 10 like this. Okay. Now, because we're dealing with money, when you enter this into your calculator, please only give to me to 2 decimal places. But do you have a calculator that you can grab to try this calculation for us?
Yes. I do.
So this is important because most of the mistakes come from entering into the calculator wrong. And you should at least have some sense that this money will grow. So it better be bigger than $10,000
Yeah.
when you give me your answer. So go ahead and punch that in and let me know what you come up with, please.
I got 27,070.
And 41 cents.
Yes.
Cents are important, believe it or not. They compound too. All right, so now we're going to do the same thing here, but we're going to change it up to where you're going to increase the number of years. So $27,000 sounds like a lot of money. It'll buy you a nice car, but it wouldn't buy you a house.
Yeah.
Okay. I mean, that's just, it's not. And by the time you're, 10 years from now, it might not buy you a very nice car either, because the car is increasing in price as well. But
Uh-huh.
it's the same calculation now. So go ahead and calculate this, and let's see what you come up with here. So the only number you're changing is in the exponent.
I got 73,280 and 74 cents.
Good. Now, what could that buy you today? What would $73,000 buy you today?
I could, probably like apartment, okay?
Okay, maybe not in a metro, nice metro area, maybe,
Yeah,
but it could also buy you a very nice vehicle. But so the two most expensive things that people usually buy in their lifetimes is a house and then cars.
yeah,
But you probably have looked at the price of cars. There's every ranges. You can spend literally anything. But beyond that, I mean, you don't really, like, you could take a really expensive trip, but it's not going to cost $73,000.
right,
But the point here is how much of this money did you start with in both cases?
10,000,
$10,000. It's already gone up 7 times, which is incredible.
right,
So let's now do it for 30 years. And notice it went up more than double in the 10 years. So let's do it for 30 years. And then we'll do it for 40. If I could do this correctly. So 30 and then 40. If you're not using second entry on your calculator, you may want to learn that. I could show you if needed, but that will help you to reduce the time to re-enter this.
Okay, I got 198,373 and 99 cents.
Perfect. So that's pretty significant. That would buy you probably, well, it'd be very, very healthy down payment on a home. You got to wait 30 years, but and then the last one here, I'll just do it for you, is $537,000. And
Yeah,
so, all right. So if you had to explain this to someone else, what would you say is the importance of time in this calculation?
it like more than doubles after you add 10 years each time.
Way more than doubles. Like you start out with 10,000 and it went up 50 times
Yeah,
now 40 years is a long time. Like when you're 16, just the idea of like 26 probably seems like incredible, but the single, and this is like the most important thing I'll probably ever tell you in all our lessons, but the single most important factor to creating wealth is time.
yeah,
And you've probably heard that before, but you're like, well, I'm 16, I got time. Yeah, you do have time, but it's like it's incredible. Because if you go, I mean, 50 years is even, I mean, you would probably never wait that long, but you just can't even believe how much money you can increase by. And there's a lot of other factors like, can you actually get 10%? Yes, you can. You actually need the money to start with, but I mean, it's incredible. The interest rate is not as important as time. Time is the most important factor in this.
mm-hmm.
So that's all I wanted to say on that. I appreciate you letting me get on a soapbox here and sort of talk to you about that. But we can work on problems like 11 now to move on. So 11A and B is asking you to compare between monthly and continuous interest. So let's talk about 11, problem like 11. So let me try to think of something else. 5,000 for scholarship. Okay, so a more reasonable scenario here is okay. I guess these are okay. So I'm just trying to think if there's anything better here. Oh, here's a better one. So you get a scholarship for college, but you have to take out a student loan because you just can't cover the difference, or your parents can't cover this, or whatever scenario. But let's just talk about student loans. Talk about it in the terms of negative. So do you have any idea what the cost of college is, either in state or out of state?
It's like 100,000 more than that. Probably.
It's a lot. It's so in-state tuitions are, I want to say 8,000 a semester, 9,000 a semester. They're growing. They might be a little bit higher now. And out of state, it's even more. But like, let's just say you get a nice scholarship, but you need to take out $50,000 in student loans, or someone has to do that. Now, the loan interest rates are about 6%, we'll say, roughly 6%, and the interest is compounded monthly. Okay, and how long do you expect your college to take? Are you on the 4-year plan, or are you on the 7-year plan?
Probably, well, 4 for now. I'm not sure what I want to do yet.
Yeah, so that's another fun conversation. There's people take a long time to go through school
Right.
on some occasions, and it really adds up here. So let's just say your time is 4 years. Okay, so let's figure out how much you will owe at the end of 4 years. So that's your A is 50,000. 1 plus 0.06 divided by 12, because monthly is 12. And it's 12 times 4 in your exponent. So will you calculate that for us, please?
Yeah. I got 63,524 and 46 cents.
Well, how many cents again?
46.
46 cents. Okay. So the idea here is that you need the money now, and you would owe this much later. And if you truly needed the money, and you were for sure going to have a job upon graduating that you knew you could pay this back, I'm not in favor of loans, but that is the reality of the world we live in. If you need it, this is the person loaning you the money wants a return. They want to know that they're going to get some money back. That's why they're loaning, because they're out the 50,000. Like, we always look at it from the perspective, like, I'm getting 50,000, but somebody had to give that money up. And by giving it up, they're saying, well, I don't need the money right now, but in 4 years, I want to get the 63,524.46. Okay.
Yeah.
Now, scenario 2 would be, okay, this time, and this is unrealistic because no money is never continuously compounded, but let's say it's continuously compounded at R equals 5.8%. So they don't have to give you any more information than that. That's because it's not monthly. It's the same number of time. It's still 4 years, because you're using PERT, PE to the RT. So your P is 50,000, E to the 0.058. Make sure you correctly convert that to a decimal, times 4. So could you calculate that for us,
Yes.
please?
I got 63,055 and then 99 cents.
Okay, so pretty close. But so we would say, well, which is the better option? And it really depends on your perspective. As the person borrowing, you want to pay back less amount, right?
Right, yeah.
But if you're loaning the money, you want the higher amount because you want to
Yeah.
pay back more. But generally, it's from your perspective as the consumer.
Right.
Like that. Okay, so this is not a real scenario though. The real scenario here that you might see, and it's I'll just give me 2 minutes to talk about this, is a mortgage.
Mm-hmm.
So generally, like, when people are looking at mortgages, they generally have to decide between like a 30-year or a 15-year mortgage. Or if you prefer like if you're buying, if you're purchasing a car, like, okay, I'm going to do it for 5 years or 6 years. Um, and then they sometimes have different interest rates. This one will be 5.5%, and this one will be 4.75%. And these are the types of problems where you really actually do want to know, well, what is the difference? And they give you usually two numbers. They say, well, your payment is some number and your payment is some number. But that's not the whole story, because in one case you're paying it for 15 years, and in another case you're paying it for 30 years. And you really want to like decide like, well, what am I actually paying for this thing? And that's what we were trying to do in this previous problem here. It's like, yeah, you're getting a $50,000 loan, but you're going to end up paying $63,000 for it. And the idea is like, let's just say you want to buy a $500,000 home, which is very out there, right now. But in terms of like, I know that you right now would not do it, but you may find that the 30-year mortgage, you end up paying like 1.1 million for the home, and the 15-year ends up only being $800,000 for the. And that's the real question you should be asking yourself, is like, do I really want to pay $800,000 for a $500,000 home, or am I okay paying 1.1 million for a $500,000 home?
Yeah.
And that's because we sometimes get caught up in the payment, and really it's like, well, what am I actually paying for this thing? Because I still got to pay it off, and it's not just the payment. It's how much am I putting towards this value?
Yeah.
Okay. So number 12, it looks like you either didn't do it the way they wanted, or there was a substitute problem for number 12.
Oh, yeah. For C, for C.
It's like you were supposed to come up with like your own problem involving money, but you gave a graph and just did
Oh,
which
he
is fine.
crossed that out and put all the, he made the graph. It's like printed on there. So
Yes.
I think he like made a different problem.
Okay,
Yeah.
great. Um, all right. So I would encourage you to talk to your parents about the money stuff, because I think it's really one of those things that like you don't get in school that could actually really
Exactly.
change
Yeah.
your life. And I would just caution you that sometimes it's awkward and talk about money, but maybe your mom or dad already has what's called a 529 or an ESA for you. I don't know.
Mm-hmm.
I'm just guessing. I don't have any idea. These are methods to save for college. And there's money that's put in at a regular interval.
Yeah.
You might ask them like what they would do different, because your trajectory right now is you're 16, you're going to graduate high school at 18, you're going to go to college and be 22 or 23 when you graduate, and you have a wonderful future ahead of you. And it's one of the best questions to ask people is like, what would you have done differently if you were 22 and had just graduated from college? And talking about like money, not just, that you go a lot of directions to that question, but like, what would you do, differently? And you'd be surprised, like if you waiting 10 years to start like investing money, we saw in the calculation there, it's hundreds of thousands of dollars and millions in some cases. So it's really an interesting conversation to have about like, what it could be, more than anything. So if you have that opportunity, I would recommend talking to someone about it. But I'm not one of those people that says like, hey, you worked all summer and you got an extra $1,000, you should go invest it. I mean, you probably should enjoy the money that you've been earning. But if you want to, you have to be really disciplined. You have to like really say, I'm never going to touch this money. It's going to let it grow.
Yeah.
But it's hard. It's hard as a young person to say, oh, I'm going to delay pleasure, as they say. So the interesting thing about people in the medical profession is they have the ability to delay pleasure, because if you think about how long they've gone to school, they've gone 13 years, plus they usually do an undergrad, plus there's like 3 years or more of medical school, plus some residency. And if you specialize, we'll just call it 2. I mean, they really wait a long time before they do anything. And that's really like they tell you in these books that money comes down to behavior. You know what, like just like when you play sports, you don't have to be the most talented. You have to have the right behavior to practice and build routines, things like that.
Yeah.
All right, I won't talk anymore on the subject. But thank you for letting me
No, of course.
give you some more
Yeah.
information.
I don't learn it in school, so it's important that I
Yeah,
do start learning it.
cool. So I know we've got a lesson scheduled for, I think, Sunday. Is that right?
Yes,
Right?
Sunday. Mhm.
Sunday at 8. If you want to start a little earlier, I probably can accommodate that. But if not, we can start right at 8, and you can just.
No, yeah, I can. What time do you?
So I'll just either message your dad or email you, but I'm going to be coming from another appointment, so I set a little buffer in there in case I didn't get back. But I would think like 7:30 if you want.
Okay, that just email or text, whatever. I
Okay,
think I'm free
perfect.
anytime.
Perfect. Great. Well, thank you so much. I guess that's it for today. I'll send you the notes here shortly, and I'll see you on Sunday.
Thank you so much.
You're welcome. Bye now.
Bye.